Okay, welcome to Pandas, data science package that is very powerful of handling data, manipulating data, and used a lot in data munging and data cleaning and data pre-processing and whatnot. This Pandas basically is built on top of NumPy, so most of the features of NumPy is also available in Pandas. Let's dive in. This Pandas is a very fancy library, very fancy package that you can handle very large amounts of data in CSV files or in Excel files, wherever the data is located. The missing entries are there. You can handle all the data, you can manipulate all the data, you can prepare all the data in just a few lines of codes using this Pandas package. So let's just start Pandas package. There are two most important objects of Pandas. One is series, another is data frame that we will see later on. There is one more index, but the most important one is, or the useful one is the series and data frame. So let's just define, first of all, you need to import Pandas package, import Pandas, and you can rename this as PD. That's the most popular renaming, although you can rename it any. And then you just say, okay, pd.series, and then just like a NumPy array, you pass the data that you want, and you can create your own indices. For example, just like dictionary, this A is a key value. This A is a key or index for this 0.25. This B is index for 0.5. C is index for 0.75, and D is index for 1. So you can supply your explicit indices as well. If you do not supply the indices, the default indices are 0, 1, 2, and 3. But you can define your own indices in the way you want. Now, once this data object is created, you can call the data values and you will find out the values. You can call data.index and you will find out the indices. Let's see in the Jupyter notebook just to get comfortable with Pandas. First of all, import Pandas as PD maybe, or something else. So okay, that's imported. Maybe we can check what version we are working in. PD.version. The version of Pandas we are working in right now is 0.24.2. Fine, great. So let's create data or whatever variable, let's say A as pd.series, pg.series, and there we just give a list of some values, 2, 3, 4, 5. Let's say these are the values, and then we can give index as another list. Let's say the indices are A. Maybe the indices need not to be strings, anything A, B, C, and let's say the index of 5 is, let's say, D. So now the series object or the Pandas object series is created. Series basically handles one-dimensional arrays. Later on, we will see data frame handles multi-dimensional arrays, more than one dimensions. Normally, typically two-dimensional arrays, but okay, A dot values. So let's call the values values, and you will get all the values inside the series. And by the way, this values array that you get, let's check what's the type of that array. What's type of that array? A dot values, what is that thing? That's a NumPy array. Wow. And what's the type of A itself? That will be a Pandas object. Great. So everything inside Pandas, the NumPy is playing all the role inside Pandas. Great. So now let's check the index, A dot index. That's also an NumPy. That's also an array of index type. That's a different. Actually, index is also an object in Pandas. That's an index type object with these kind of indices. We can access, for example, this A just like we are working with dictionary. For example, A of A, that returns a value. We can change the values. We can add we can add more key value pairs. So just think like just think this data just like the dictionary object that we saw. These are the keys and these are the values. And this is one very good way of remembering what the series does and manipulating series the way we want. Okay, one, we can access like this. We also can do slicing. Let's say we want to access from A to, let's say, C. Let's say we want to access all these. One difference is when you access like this, in the normal slicing using implicit indices, for example, 1, 2, 3, or 0, the final index is not included. But if you access like so, using explicit indices that are there, the final index is also included. So that is one more fancy way of indexing using in this pandas. Okay, great. That's a series object. By the way, we can create a series object by first creating a dictionary. For example, let's go back to our slides and see this example. Let's create a dictionary, for example, of grades. Let's say we have a lot of students with grade A minus, grade B minus, and let's create that dictionary. Then we can just create a series object or pandas object by just passing this dictionary inside. We can make another dictionary, for example, and we can make another series object. So one way of defining the series object is just to pass the data as well as index. Another way is to just first create the dictionary and just pass the dictionary variable inside, and the series object will be created. Okay, that was just the introduction to series. We will move on and see more features of pandas as we explore it more and more in the upcoming videos. Hope to see you in the next video. Two different dictionaries. Let's say we have a lot of students, and the A grade is defined to be 4 and the A minus grade defined to be 3.5. The B grade has a number 3. The B minus grade has a number with a numeric value that is 2.5, and similarly B grade has a numeric value, let's say 2. And then we create just a series object using this dictionary. Let's say rather than just numeric values as GPAs or something like so, let's say A grade also is defined at 85 marks in total. A minus grade is defined at 80 marks in total, and similarly these. And then we create another series object, let's say named with marks using these PD dot series. So let's go to Jupyter Notebook and just play a little with these dictionaries and build the series object. Let's say marks, or let's say grades dictionary equals, let's say A grade is has A grade has number value 4 or GPA value 4. Let's say we have a B grade with GPA value, let's say B is, let's say, 3.5. Let's say we have C grade with GPA value, let's say 3. And let's say finally we have D grade with GPA value, let's say 2.5. Let's say that's a dictionary. Okay, what we do now is we create a grades series object, let's say, using pd dot series, and just pass this grades underscore dict. Now this capital A, capital B, capital C, and capital D, they will act as indices, and this 4, 3.5, 3, and 2.5, they will act like values. So for example, if we call that and just now call grades dot grade dot values, so we will get, for example, what is that? That just values. Let's say we get this grades dot values, and we get all the values that are available. Similarly, if we find grades dot index, we will find out A, B, C, and D. Let's define another dictionary, for example, marks dictionary dict, and that is, let's say, again, the total marks are 85 for the A grade. Let's say for B grade, the total marks are, let's say, 75. Let's say for C grade, the total marks are, let's say, 65. And for D grade, let's say the total marks are 55, let's say. So let's say that's another dictionary. Now let's create a series object pd dot series, let's say marks dictionary. Yeah. So now again we have, if you just write this marks, just like so, you will see the marks: A is 85, B is 75, C is 65, D is 55, and all the values, they are integer 64 kind of values. Now we can access, now we can play with this marks. For example, if we just want to access, for example, what are the marks? What are the marks between, let's say, for example, what are the marks given at A? We can access that, we can change that, we can just play like a dictionary. What if we, rather than using the index A, we use, for example, slicing? We want to start from the very beginning, and let's say we want to go to 2. What will happen? Let's see. Yeah, so the slicing is there. For example, if you want, these are explicit indices, A, B, C, D. These are explicit indices and they are there. For example, if you can slice the data using explicit indices that you are given, or implicit indices that are the default indices. The first value indexed at 0, the second value is indexed at 2, 1, and so on. So you can do that as well. One catch here, for example, that we will see later on, there may be a problem that your explicit indices, they are also numeric, and then you do the slicing like so, then the series object may be confused whether I have to use the explicit indices or implicit indices inside. We will see how to resolve that issue, but by this pandas allowed to use explicit indices as well as the implicit indices. Okay, we were here. Sorry, I just. So yeah, so we were here. So we have created these grades, a series object. This marks as a series object. The series object is good for one-dimensional arrays or data with just one-dimensional list, or dictionary kind of with just one dimensions. Later we will see data frame that actually is actually the extension of, can be look like as an extension of series towards more than one dimension. We may have, for example, two-dimensional arrays or two-dimensional data structures, something like so. And we will be seeing this data frame, which is much more powerful, particularly for reading data from files and manipulating it and stuff like so. We will see that in the next video, data frame, that running form of data frame in the next video. Hope to see you in the next video. Okay, in the last video we were discussing series, and I told you that data frame is basically if the data has if the data is in a form of different columns, for example, a record as an array, then you have another record, then you have another record, and each element in that record is a different attribute. So this particular way of two-dimensional data is very well handled using data frame inside pandas rather than series. So but you can make these data frame object using different series objects. For example, you have a grades object that we created last time. You have a marks object that we created last time. Let's build a data frame using these two and see what it looks like in Jupyter Notebook. Let's see that. So remember, we have a marks series object, and we have a grades series object. Let's now make grades. Maybe the name is grades. Okay, the name is like grades. Okay, so grades object, this one. Let's make a data frame. Let's say D, or maybe whatever name you want to do, data frame with, again, that data frame can also be defined using a dictionary. Again, now we have, let's say, marks is the key for data marks, and grades is the key for data grades. Let's say we define a data frame like so. And now if you see, if we just display this D, we get a very beautiful look and feel of, I mean, this A is the index, A is the explicit index. At index A, the marks is 85, the grades are 4. At index B, the marks are 75, the grades are 3.5, and so on. That looks like so. Not only that, you can just transpose it like you have transposed the NumPy array, and you will get the flipped variant or the transposed variant if you want. Great. So that's how, and you can have, for example, more dictionaries to concatenate together, and more columns will be added here. And that's what the real data looks like. I mean, it has a lot of columns, which normally are attributes, and each row is basically one record or one sample of the data that you want to work on. So this data frame is really, really ideal data structure for working with files, having a lot of records, and you want to manipulate that data and stuff like so. So yeah. So one more thing. Let's access the D, for example. Let's print D. That's the D. Let's access the values inside D other than no. So what are the values? So the values inside D is completely, again, a two-dimensional array that is completely like so. So for example, if you want to access this particular element 65, that is row number 3 and column number 1, excluding the indices. That's row number 3 and column number 1. So we can access that particular value, D dot values, just assuming that's a two-dimensional NumPy array. Row number 3 is 2, indexed with 2, and column number 1 is indexed with that, and we will be able to access 65. Wow, great. So that is there. There are more things that are available. D dot, for example, columns, D dot columns. It will give us what are the columns. The columns are marks and grades. There are other properties, and there are other several properties that we need to know. RS, for example, this there we define this as D dot index and stuff like so. Okay. One more thing that you need to know is we right now we have, let's say, D, that is this one. That's D. Let's say we want to add another column here. We want to add another column here. And that is the name of that column is scaled marks. And the scaled marks are, what if we have computed marks rather than from 100? What if we have computed marks out of 90? What are the scaled marks out of 90? So one way to do that, and very quick way to do that, is just like a dictionary, again, like a dictionary. You just add a new key, let's say scaled marks. That's a new key. And the value is simply all the marks column divided by 90. So is that true? No. Divided by 90. If we have just computed all the marks by 90, and then how can we compute the marks from 90? It is, rather than 100, it is from 90. I guess. How can we compute the marks from 90? If you want to compute the marks from 90, I guess they will look like divided by 90, and maybe 100 is multiplied here. I guess maybe the formula, I guess that's what it is, I guess. Let's see. So now if you see D, there will be another column that is there, and it does something else. Anyways, I mean, it does something that, yeah, so something. Anyways, so we have just, I mean, we've just computed this. We just found, we just inserted that column inside that. I mean, that is a processed version of these kind of values. Maybe we have added this column in a very wrong way, and later on we suggest that, okay, we should delete that column. Well, that's very simple. Again, using the concepts, again, just like the dictionaries. Delete this, and this column is deleted from data, and you are again with the data that you had. So you can add columns, you can delete columns, and Indexing is really fine. I mean, indexing like masking. Let's say you want to pick, for example, or you want to pick the data frame such that you want to pick all the records such that are the marks are greater than let's say 70. You want to pick all the records where the marks are greater than 70. This is that simple. All the data will be copied into G with this condition. And this condition can be arbitrarily complex using ands and ors and combinations and all that stuff. And you have seen this kind of stuff in NumPy as well. I mean, this is called masking. Great. So that's available in Pandas as well. Okay, so that's how you can index. In the next video, I'm going to basically show you one type of problem that normally happens in real data, that is the missing value problem. Sometimes you read a data and some of the attributes or some of the row column pair values, they are just missing. I mean, they're not available due to certain reasons. How can you handle those values, and how actually Pandas suggest you to handle those kind of missing values, which is sometimes called nan values or none type values also. They mostly used interchangeably in Pandas. So in the next video, we are going to handle or see how to handle missing data in Pandas. Hope to see you in the next video.
So we started a new topic, pandas, and pandas is actually very, very, very cool and helpful. So it's an important topic. Let's make sure we have a good grip on each and every point of pandas. So here's your task. Make a data frame D. You make a data frame with the name D. It should have two columns. One should be a name, which should be string type, and the other should be with the name of vaccine, which should be a Boolean. And make 5 entries in this data frame. Store the names. Your task is to store the names with true vaccinated records in a new data frame, which should be named M. So this is your task. So the new data frame M should contain the names and vaccinated records, names of those whose vaccinated records are true. So yeah, that should be contained. And this is it's not at all difficult. Just try it, and we'll see this in the next video. So let me just make this clear once again. You have to store the names with true vaccinated records in another data frame M. So the new M should contain the names, and also it should contain that the vaccinated record is true. So yeah, that's your task, just clearing it once more. Okay, I'll see you guys in the solution video. So let's solve this quiz together. By the way, it's I've mentioned this before. I'm gonna just mention it again here. It's totally okay if the solution that you guys come up with contains maybe some steps before the other steps, and maybe my solution contains those steps later. So that's totally fine. The order does not matter, and it does not matter how you do it, as long as you're using the right methods that are being taught by Kashif. So yeah, so I'm just gonna, so okay, let's solve it together. Okay, so let's okay, what I'm gonna do is I have to make a data frame, right, with two fields in it. That's a name and I think vaccine. That was the name. Let me just check it. Make a data frame. Yeah, with the name, which is string type, and vaccine, which is Boolean type, right? And how can I do this? Let's say I'm just going to make two dictionaries first, and then I'm going to pass it to the data frame. You can do it directly, up to you guys. So let's say I have name is equal to, let's say there's A. This is the key, and this is the value. Let's say Alan. Okay, and B John. So we're supposed to make, I think, 5 entries. Let me just check again. Yeah, 5 entries. So then there's C, Cindy, and D, let's say Stacy, and then there's E, which has Diana. Okay, no syntax mistakes. Yeah, okay. Now the other one is let me just name it vaccinated. Okay, so we have, let's say I'm just gonna rename the keys A, true, and B, let's say this one is false, it's not vaccinated. Then C, let's say it's again false, and we have D, let's say true, and then last one is E. Okay, let's say this is false. Okay, no syntax errors. Good. Okay, so now let's make our data frame. We have the data, so pd dot data. Okay, and by the way, I have imported pandas here. Before doing all this, I imported that, so that's compulsory. So pd dot yeah, I want data frame, and first of all, there are names, right? The first entry is of name, and the second one is vaccine, and I'm gonna pass that one vaccinated. Okay, so what I've done here is I made 2 dictionaries, name and vaccinated, and each dictionary contains all the data, the entries, and all I've done is created a data frame, and I just passed the dictionaries instead of writing the whole all the datas here. It's just it's up to you. I just think this is a bit organized, you can say, maybe a bit it looks good like this. Okay, so let me just check D. Okay, beautiful. We have names here, we have the vaccinated records here. These are only 2 fields. You can make as much as fields as you want as required. So this is a very good way to organize data in this kind of a way. Okay, so let's so the next task was to store the names with true vaccinated records in another data frame named M. So let's just quickly do that. There's D. We want to get the data from D that has vaccinated records as true. Right? This is how you do it, right? I want to fetch data from D. The values of D, vaccinated values of D that are true, and store them in M, right? So let's check M now. There we go. Alan was true, and Stacy was true, and all the other values are false. Okay, so yeah, done with this quiz. See you guys in the next video. Thank you, everyone.
In the last video, we saw data frame object, and we saw actually how to add and remove columns, how to process data, how to index, how to actually mask, or how to apply conditions and selections in Pandas. We saw that very briefly, but in this particular video, we are going to see one kind of missing value, sometimes called nan, or not a number, or maybe not anything, or sometimes this none type none, which is the default return type of any function in Python. This none type is also sometimes in Pandas is treated as nan, or nan is treated as none, or interchangeably anything. Let me give you what do we mean by that. Let's say we have two dictionaries. Let's say one dictionary is A with key value A, and the value is 1, then B, and the value is 2. Okay. The other dictionary is B and C. So for example, that is one record with columns A and B. So A and B are the columns. On the first record, the value of A is 1 and the value of B is 2. Now let's say we want to insert another record in the same data frame. Now the value of B is available in the second time. The value of B is available, which is 3. And the value of C is available, which means a C column is added now. But for the value C, the first row value is not available. So we will say this value is missing here. But in the second row, we have 4. Similarly, the value of A is missing for the second row. And that is a missing value, which is sometimes called nan. So these are missing values, and they are typical when you are working with data and you're reading data and you're getting data from somewhere, or large files and stuff like so. So Pandas give some methods to handle these kind of this kind of situation. Let's say A equals PD dot data frame, again a dictionary. Let's say we have A 1 and B, let's say 4. That's the first row or record. The second record, let's say, is another dictionary. Let's say B is -3 and C is, let's say, 9. Let's say that's our data frame A. So now if you print this A, if you see the data inside A, you will see, oh, what's the problem? A is this, and B, have we applied something in a wrong way? Let's see. Yeah. Oh, we have to create a list. That's the, okay, we have to create a list of it. You have to create a list of dictionaries. That's the proper way of calling it. So we missed just the syntax list of that. Okay, great. So now we have this A, we just call that A, and this value is missing and that value is missing. And in large data files, this is typical. I mean, there are a lot of values that can be missing. One way that Pandas applies to handle these missing values is to just fill these missing values with some fixed number. For example, there's a fill na function, and let's say you supply a 0. That means wherever there is a not available or not a number value, fill that with 0, or maybe any value you want to fill that with. So that is one way to do that. And now if you see, the value of A is all the non-values are filled with that. Another kind of function that is available in Pandas that is sometimes used, that is drop na. That function drop na. What that does is it drops all the records that contain a missing value. Sometimes if that is feasible, I mean, dropping all the records that contain missing values, if that is feasible, then go for that. But if the missing values are a lot and they are spread over a lot of rows, then dropping all those kind of records, they will create a lot of data loss, and then it become really important how to handle these missing values. However, you can fill the missing values using fixed value, or you can drop them. And later on, we will see in scikit-learn that there are other ways of handling the missing values as well. You can fill each column missing values in each column using an average, or using, for example, a regression. There are ways to handle these missing values. But in Pandas, these two functions are right away there. You can fill all them with a fixed value, for example, or you can drop them and you are ready to go. Okay, great. Next, we are going to see, as I mentioned earlier, what is a confusion between, what if there is a confusion between implicit and explicit indices, and that I will discuss in the next video. Basically, just to give you a look and feel, what if the explicit indices you supply, they are 1, 3, and 5, and what if you call this particular command 1:3? Will it call the implicit index or the explicit index? That's a problem. So we will see, because 1:3, 1 and 3, they are also explicit indices. And whether this 1:3 is referring to the implicit indices that are default indices, or they are referring to these indices. So this confusion is there, and we will see how to handle that confusion using this lock LOC function and index lock ILOC function. We will see that in the next video. Hope to see you in the next video. Okay, in the previous video, I mentioned a confusion that can be there if you have supplied the explicit indices that can conflict with implicit indices. In particular, for example, if this is the series object, or maybe a data frame object, if you want to, if for indices, let's just think about the series object. It has these values A, B, C with index 1, 3, and 5. If we, for example, access a particular element, let's say data with index 1, that means the explicit index for sure. But if, for example, we slice the values, for example, 1:3, the default behavior of slicing, if you give the numeric indices, that is to use implicit indices. And by implicit indices, we mean that what is at index 1? At index 1, this is B. So B will be printed, for example, or B will be fetched. And then you move to 2, which is C, then C will be fetched. And these are the values that will be printed. But the behavior might be different. You might be expecting to use explicit indices, which means access 1:3. And when the explicit indices are used, the last index is also included. And in that case, you might be expecting the index 1 is of A, so A should be printed, and index 3 is of B, and B should be printed. And this confusion might be there if this is there. So to handle that, there are two functions. One is called LOC, and another method is called ILOC. Whenever you call LOC, that means you are using explicit indices. I mean, you're forcing to use explicit index. And whenever you call ILOC, that means you're accessing elements using the implicit index whatsoever. So let's practice this and see the confusion, see the detail of this kind of confusions in here, Jupyter Notebook. So let's say we have a series object. Let's say A equals PD dot series. And let's say it has values as A, B, and C. That's the value. These are the values, and index as, let's say, 1, 3, and 5. Let's say these are the indices. Let's say this is A. Okay, let's say we access A using 1. That means the explicit index, and that is this. Let's say we access using a slicing operator. Now this will use implicit indices, and it will access it will access these B and C, because 1:3 using indices, implicit indices results that. And we might be expecting that use this kind of stuff. So if we are really interested in using explicit indices, what should we do is we should call the lock function, a lock, and then 1:3. That means use explicit indices. That is to remove the confusions. Now it will use the explicit index 1 and 3. And if, for example, we are interested in using implicit indices, then it is good to use iLock function. Yeah. Now 1:3 is to use implicit indices, and the implicit indices are like these. So and like in series objects, you can do the same in data frame objects. Once you are using lock and iLock, then the further indexing inside these square brackets is exactly the same like NumPy. So whether you use lock or ilock, the indexing mechanism is exactly the slicing mechanism is exactly the same like you have used in NumPy. I mean, all indexing that stays the same. Lock means you're using explicit index. Ilock means you are using explicit implicit index. Let's say, for example, we have our data frame, I guess D. That's our data frame available to us. Let's say I want to access d.ilock. Let's say I want to access the second row completely, the second record. The record that is indexed at, look at index at 2, which is the third row completely. Let's say I want to access that. Now this 2 is acting as for example, if you see the second row or the row at the second index, which is the third row, that is completely this, and it returns that. Once you have used ilock, for example, and mostly people use ilock, sometimes lock is also required, but ilock is just to explicitly mentioning that I'm going to use the implicit indexing scheme. Again, you can consider whole that thing as a matrix, and once you have applied this ilock, then you're free to play with the indices like you play with two-dimensional arrays. For example, I want to, for example, I want to reverse, for example, all the rows, and I want to reverse all the structure, for example. Let's say I want to do that, and you can see everything is reversed. I mean, all the indexing, like NumPy, all the indexing is there in Pandas. I mean, once you have used ilock, inside is just remember the NumPy indexing and everything like so. Okay, so that's the lock and ilock function. In the next video, we are actually going to just practice the pandas to actually work on a data file that is saved as a CSV file. So we will show you how to actually manipulate, read, and write the data and play with the data, the real data that is there in some CSV file, and how pandas will help you to manipulate the data very efficiently and very quickly. So hope to see you in the next video. So let's start. Let me just copy this path here. The path is this dull data. So let me copy that path and let me go back to Jupyter Notebook. So let's work with this file and see what happens. First of all, let me define a variable where I want to save this file, pd.read CSV function. That function is available. And here I basically read this file. Okay. I have placed this R in front of that so that I am forcing that these backslashes, they should not be confused with the escape sequences. They should be used, they should be considered as raw formats. If you now see, if you pick actually the data has been read, if you see the shape of the data, the shape of the data is, it has 32,560 records. Each record has 50 attributes or columns. If maybe you want to see the columns, what are the columns? What are the columns? The columns are, wow, the columns are 39, state go. What is that? Why are these columns? Basically what happens is this file does not have a header. So the very first record actually is acting as a column, although it is not, these are not columns. That is actually the very first record. I have to, when I call the function, read CSV, I have to force it that the header, there is no header. So don't confuse the very first, so I will place this header equals none. That means don't confuse the very first row as a header. Now you see the number of rows, they actually increased by 1 because the very first row, it was confusing that with column headings rather than actual data. Now this does not have any columns. So the default indices are basically starting from 0, 1, 2, 3, and all that. We can I mean define the columns. We can rename the columns. For example, columns equals to, let's say C plus str x for x in a range df dot shape df dot shape 1. So what this code does is it actually assigns column 0, column 1, column 2 as string names. So let's see. Now if we see df dot columns, it basically becomes now the basically 15 columns starting from 0. Now we can access different, we have df, for example. We can access, let's say we want to see column 14, for example. What are the entries in column 14? These are the entries. If you want to know more and more columns, we can see those entries as well. So for example, column 14, then we want to see, let's say, column 0. We want to see these entries. Oh, we cannot see that. Why not? Oh, basically we need to use a log function, because we are accessing, if we want to access these columns, we should be using log function rather than these. So why don't we use log function? So dot loc, we are going to use the explicit indices. Let's say C0, and then we want to use, let's say, C14. And it again gives me a problem. Why is that? Maybe C0 key error. C0, that there is an error. I'm not able to actually see column 0 and column 14 together. Why not? That's a problem. I should be able to see those together. I can see this individually. Oh, I cannot see this individually either. Why not? Is there some problem? Let's say C0. Yeah, that is there. So that is there. Why don't I, if I, for example, use dot loc and I call OK C14, what's the problem? Oh, these are columns. So I should first write the row index as colon, because I'm accessing just the columns. So I should mention that access all the rows for this particular column. On the other hand, if I want to access, for example, 0, I will say, okay, access all the rows using log function, access all the rows for this particular column. Now, what if I want to see both these C0 as well as C14? What if I want to see? Maybe I can use the indices that I learned, an index array. I learned that in NumPy. Maybe I can use that and everything will become fine. Oh my God. Yeah, it's working. So now this is an index array, and that is, so I'm using the log function because these are explicit indices of columns and all that stuff. And so let's play with this data a little more. Let me just write, for example, df.head. That function actually is there that displays the top 5 rows of my data. So these are my top 5 rows indexed with all these kind of columns and stuff like so. Let me process this data more. For example, let me, oh, by the way, there is a tail function as well, df.tail, that actually give me the last 5 entries in the order. So let me see, for example, by the way, if I just go to the description file, the description file basically says that the task, if I really want to, if I tell you the task, here the task might be written somewhere. What do you really want to do? what predictions you want to do here. What's the task? So basically, they have written the task here. What I really want to do with this data. So that's our data. And okay, so the task really is to find out the probability for the label, find out the probability whether a particular adult is earning more than 50K or not. So the values are more than 50K and less than or equal to 50K. So that's basically a classification data set. So let's see, and that's a 14th column in our data frame. Let's see that. So if we just see df, let's say C14 dot unique. If I just see what are the unique entries, these are the unique entries. If I just copy these unique entries in an array, let's say unique entries or labels, class labels as this. So if we now see the labels, label 0 is basically this, and label 1 is basically that. And these are the only two labels. So what if I really want to replace this label 0 with -1, and I want to replace this label, rather than these strings, I just want to replace them with -1 and 1. This is classification data. Why don't I use -1 and 1 labels rather than less than or equal to 50K as a string and greater than or equal to 50K as a string? So how can I go and change this particular column? How can I do that? First of all, let me find the index where this happens. So what is the index where this df C14 basically is equal to this particular value? What is the index? So that will be a Boolean index here. That will be a Boolean array. Somewhere it will be true, somewhere it will be false. Now I really want to basically change the values where this index happens. So df C14 dot Boolean indexing in Pandas basically is considered to be, it resembles to explicit indexing. So you have to use lock function rather than ilock. Dot ilock index, and this particular index you just place a -1. Okay, will that work? Yes, I guess. And what you do next is that's a warning. Don't worry about it. It is a warning because this slicing actually gives the same memory view in Pandas as well, and we are overriding a file using a sliced variant. So it is giving us warning that be careful about copy and view variants of Pandas. So next, what we do is we take the complement of the index. So we just reverse true and false and place a 1 wherever the other class lies. So that's what we did. And now if we see df 14th column, column 14, it will give me the values -1, -1, somewhere 1, somewhere -1, and all that stuff. So if we now see unique values, df in C14 dot unique, if we now see all the unique values are -1 and 1. And if we see now the structure of our data frame, it just have the last column, which was first showing as less than 50K, and now it is showing as -1, 1, -1, 1, and all that stuff. What next? What we do next is basically we are going to convert this C1 column. It has a lot of, for example, different kind of job titles, state, government, self-employment. We're going to convert this C1 column using one hot encoding. So one hot encoding is basically sometimes used to convert the string data to numeric data for further use. So for example, and there's a function in Pandas called get dummies that actually helps doing that. So first, let's see how many unique entries are there in that column. So df c1 dot unique dot size. So that will give me the total number of unique entries in that column. So this particular column has 9 unique entries. So when I will convert using one hot encoding, this particular column will expand to 9 columns. So basically in place of one column, we'll be having 9 columns because there are 9 entries, and one hot encoding actually, that binary encoding actually depends upon the total number of these types. So what I really do is df equals pd dot get dummies function that actually does that stuff for me, get dummies, and what columns I'm really interested in converting to one hot encoding. Let's say C1. I just want to convert that, and that's okay. So now if I see df.shape, earlier my df.shape was having 15 columns, but now my df.shape has 23 columns because one column is gone and 9 more columns are being added. So 15 minus 1, 14, 14 plus 9, 23. Now if I see df.columns, if I see these are so many columns, C0, C2, and all these columns, but C1 column is now actually more than. So C1 this, C1 that, C1 that, and all these kind of columns. So that's what this C1 basically goes to. So 15 columns earlier, one column gone because C column is gone, and next C column is gone, and one column is gone, and 9 new columns are being added. So the result basically is 23. But here you might be seeing one terrible thing. What is this particular column? C1 underscore question mark. Maybe there is a null entry in that column, and that null entry is also specified as maybe there are missing entries in there. Oh, I haven't encountered. We actually haven't encountered the missing entries. Let's go back and see whether there are missing entries or not. Right now we have changed. This df because we have copied this result to the df. We have overwritten that. Let's just go back and read the file again and see whether it has missing entries or not. If it has missing entries, we have to work about it maybe differently. So let's say that df. So let's say df dot columns equals c plus str x for x in range x in range, and p dot x in range, let's say df shape 1. So these are my columns. So df c1 is null. Is that? Oh, it looks like false everywhere. So maybe we should call some function. How many null entries are there? Oh, there is no null entry. Then why that when I convert, oh, we were working on C2, I guess, or C1. Oh, C1. So why that? So let me see the unique values in that. df c1 dot unique. Let me see all the unique values. So, oh, one value basically is like this. So this is one value, this is another value, this is another value, and all that. And one value is just a question mark. That's amazing. Yeah, so it's okay. Whatever we were doing, we're perfectly fine. So df is, let me call that df2 equals pd dot get dummies df, and columns. What columns we are interested in is basically, let me see, let me convert the C1 and let me convert the C14 columns as well. C14. In that case, both the columns, they will be converted from string to, so this column will be converted from string to one hot encoding, and this column will be converted from string to one hot encoding. And remember, this column just has two distinct entries, so 2 columns will be added because of this, and 9 columns will be added because of this, and the original columns will be deleted back. So, oh, what's the problem? Columns equals to, so that's what we miss. So if we now see df2 dot columns, if we now see df2 dot columns, it has several columns now. So several columns due to C1 and several columns due to C14. Let me see whether there are let me see whether there are null entries or not. So let me just yeah, I mean there are no, there are no, see, there's no null entries. All the entries, I mean there are no missing entries. If there were missing entries, we could have taken care of those as well. It looks like there is no missing entry. Yeah, great. So one way to see the information of df is basically to just call the info function and see how many missing entries or other kind of stuff here. So column 1 has these many entries, all of them are non-null and stuff like. If there are null entries, for example, for a particular column, you might be seeing lesser number here than the total number. So now if we just see df2 that we did the one hot encoding for, df2, so that df2 looks like that. It is pretty much like same as earlier, but if we see some of the columns, like the columns here, all these columns, they previously were strings, but now they are converted to binary numbers. And we can apply further processing on these binary numbers, or maybe using scaling and pre-processing that we do on data, and to do it more. We can convert a lot of columns to their one hot encoding just at once. We can if we don't want to convert one hot encoding, just we want to loop over unique values, we can assign them numeric codes by ourselves to convert the data to numeric form. And the reason is the machine learning algorithms, they really require the data in numeric form. So we can convert, for example, all this, all the columns. If we want to write all the columns that contain strings, we can convert all of them just with one command to one hot encoding if we want, by this function get dummies. There are several other functions as well. So let me write this data frame into a CSV file. Let's say df2 dot let me do cs to CSV. Let me write that to CSV, and let me write the name of CSV as where should I write that? Let me write that in, again, a data folder. In this particular folder, let me copy that, Control C. Let me write that file here. So R, Control V, and let me write that file name as abc.csv. So this file should have been created there. A little modification that we have done, you should see these modifications in this particular file. We can open up this file in Excel. Yeah, if you really want to see that. Let me just go and format to fit column width, and so that's the original file. These are the columns that we did not disturb, and these are all the columns that we actually converted to one hot encoding, including the class labels there. You can further read this file at some other time to make it more, to process it more and stuff like so. Okay, in the last video we talked about, we basically practiced some of the concepts of data frames or pandas on a CSV file, adult.data. That CSV file was that is available publicly on UCI machine learning repository, or maybe at other resources as well. Now that you know that you can apply all these concepts on CSV files, on the real data files as well. Let me continue our discussion on exploring more functionality of pandas, sometimes using on just synthetic data and maybe sometimes on files. So another very powerful feature of data frames or in pandas is group by. What really happens is, assume you have, let's say, assume you have a data frame with, let's say, column 1, and then you have column 2, and then you have, let's say, column 3, and let's say you have a lot of columns, let's say column n. So what you do really is, let's say column n is numeric type. Let's say it has integer or floating point numbers. And what you can do now is you can group all the data with respect to column 1. If you really want to group the data with respect to column 1, what will happen is all the distinct entries in the column, let's say column 1 has, let's say column 1 is just type of a particular product. And the total types are, let's say the total types are just A, B, and C, let's say. Then all the records of type A, they will, so when you will apply this group by with respect to, let's say, column 1, all the objects of type type A, all the records of type A, they will combine here. All the records of type B, they will combine here. All the records of type C, they will be combined here. So here you will group all the records with respect to their type. That was, so first go is splitting. Once the splitting is done, then you can apply any aggregate, maybe a sum or maybe a mean, or any aggregate. After aggregating, what will happen is the aggregate will apply on each split individually. So it will apply on, let's say, A, and all the values will be summed up, and you will get one value at the end. And then this sum will be applied on this particular group, and you will get one value, and the sum will be applied on this group individually, and you will get one value. Once the aggregation is done on different splits, then these different splits again get combined, and you will be having A, sum of all the A's, sum of all the B's, and sum of all the C's in this particular way. So the result basically is you first split and grouped with respect to a column, that is an attribute that you have specified. We will see multiple attributes as well. You can specify multiple attributes. After splitting, each group now becomes a different group, and then you apply aggregate on each individual group. After aggregation, you just combine the result of aggregation back, and you get a data frame. That's very, very powerful feature of data frame. Sometimes we need to actually analyze data with respect to different categories and different values. We want to see the trend with respect to each type and stuff like so. Let's go to Jupyter Notebook and just practice what we've just seen here. So let's see. So for example, let me for example give you for example, let's generate a data frame. Let's generate a data. Let me see if I have already imported pandas or not. Let me just import panda again. Pandas as PD, because this is a different notebook that I'm working in. Just just to make sure that the Pandas is imported properly. So df data frame is pd dot data frame. Let's build a data frame, and let's build, for example, let's build, for example, a product. Let's say product. That's the product name. Let's say product name. That's one column. And the product name is basically, the product names can be, let's say the company produces two kind of products. Let's say bulb. And so we have a bulb. We have another bulb maybe. And we can have, for example, a fan, and we can have another fan. That's our data. Let's say that's one field of the data. That's it. Okay. Then maybe another field is the type of these products. The types might be the type of the first bulb is type A, and the type of the second bulb might be of type B. The type of the first fan is type A. There are two types, let's say, type A products, type B products, and the type of the second fan that is in the list is also, let's say, A. So these are all the types, let's say. Yes. And let's say we have another parameter, let's say light consumption, let's say it's a light consumption parameter. And let's say this light consumption or the energy consumption, let's say the energy consumption parameter is, let's say that parameter is numeric and it has some units. Let's say, for example, 400, 300, let's say. So bulb of type A that we have just noticed that it actually consumes 400 units of energy, and the bulb of type B just consumes, for example, 300 units of energy. Fan of type A that we have just focusing now, it consumes basically, let's say 250 units of energy. And let's say another fan that is also of type A, we just noticed that it actually is consuming let's say 300 units of energy. Let's say that's our data frame. Let's say. So if you see data frame, if you just see the data frame, that basically is the following. It has product name, type, and energy consumption. Here, this energy consumption is really a numeric field. For example, what if we just want to see group by? If we just see what kind of so if we, for example, product name, what if we want to group all the data, all the energy consumptions with respect to the product? So here you can see the bulb actually the energy consumption, the total energy consumption of bulb of all the types, that is 700, and the total energy consumption for all the fans, that is, for example, 550 units. That is independent of type. So what basically happens is we first pick the bulb and then pick all the data corresponding to record 1, record 2. So the data basically consists of this 400, this value 400, and this particular value 300. And then we apply a sum on that, and the first result appears to be 700. Then we pick, for example, all the data with respect to fan type, because since a fan has this record, fan has this record, so we just add them up. We could have applied another aggregate other than sum. For example, we could have applied mean maybe, and in that case you will get the average value of all these. Further, we might be interested in grouping all these with respect to the type rather than the product. So, for example, what if we just give this df dot type. So that's another way of giving the column name, df dot type. And with respect to that, if you see, so type A, let me apply the sum here. Yeah, sum. So type A basically has total energy consumption as 950 for all the products in type A, and the type B has total energy consumption 300 for all the types that are there in, and you can see that actually is the case. Another thing that you can do is you can group all these things with respect to multiple columns if you want, multiple attributes. So for example, df dot group by this, and here you write okay df dot product name, and then you apply okay df dot type, and now you just apply any aggregate, and the result you will be see will be very, very cool. So for example, that's the result that you're seeing now. That's the command. I should show you the command as well. That's the command. Now it first group everything with respect to the product name. So it picks the bulb. Now inside the bulb, it picks all possible types inside the bulb. If you see the data type inside the bulb, there are two types, type A and type B. Now inside the bulb, it picks A, it picks B. That's the total split. But because we force that also group them with respect to type, it represents the total sum with respect to type A separately, total sum with respect to type B separately. On the other hand, if you see the fan has basically, when you see the fan, it basically splits with respect to the fan. But in the fan, we have just the type differences are just A. So it picked both of these values and apply an aggregate on that. And the result basically is 550 that you can see here. Yeah. So, and you can have this group by on multiple columns, and you can just group the data. You can just arrange the data. You can just apply the aggregates using this group by. So consider, for example, we have a just consider, for example, we have a data set that has different attributes. Let's say one attribute is country, another attribute is date, and let's just think about a COVID-19 data set where we have country attribute, we have date attribute, and the total number of patients reported or confirmed cases, the total number of deaths at that date, and the total number of recovered cases at that date. What if we want to see the trend for each particular country? So we will definitely apply the group by command on the country attribute. What if we want to see what if we want to group the data with respect to country as well as the date? So in each country, there may be several provinces. In each country, we have several dates in that country, date 1, date 2, date 3, and all these dates. So first we want to split with respect to country, then we want to group them with respect to date, and then we want to see the grouping with respect to country and date in that particular manner. So either way, this group by command is really, really helpful sometimes to see and to summarize the data very, very well. So yeah, in the next video, I'll be talking about hierarchical indexing. That is one more powerful feature in this kind of framework, and I will talk this hierarchical indexing particularly in the context of group by, where we want to actually group different data, group the data with respect to a particular field in particular levels. So let's see the application of this group by hierarchical database or hierarchical structure in the next video. So hope to see you in the next.